Hey guys, so we are talking about independent and dependent events. All right. So in probability, there's lots of different types of events, but two of them are independent and dependent. So what I want you to do is go ahead and jot down the definition of these. So independent is when you have two events or more than two events and they don't depend on each other. I know that's kind of obvious, but let's say you have two bags of, I don't know, donuts, and you're choosing a donut out of each one. The donut that you choose from the first bag does not affect anything in the second bag, right? So those would be independent. Dependent events is when you do two things or more than two things and they affect each other. So let's say you have a bag of coins and you pull out a coin and then you pull out another one. If you keep the first one in your hand, you've now affected how many coins are left to pull out, right? So those would be dependent events, okay? And then the last definition here is conditional probability. So conditional probability is the probability that event B occurs given that event A occurs. So you are assuming that the first thing's going to happen, and then you do the probability of the second thing. So they're dependent, but it's a special kind of dependent probability, okay? If at any point you need to pause the video, to jot something down because I'm talking too fast, please feel free to do that. So the formula for probability of independent events. So if you have two events and they have nothing to do with each other, I mean, they might have something to do with each other, but they don't affect each other at all, like my donut example, then the way that you figure out the probability of both of those things happening is you take the probability of the first event, which we're calling A, and then you take the probability of the second event, which we're calling B, and you multiply those together. Okay, so it's typically, you can use it as a fraction or you can use it as a decimal. Then you multiply those two things together. Okay, fraction or decimal would be fine. All right, we're going to take a look now at dependent events. So dependent events, what you have to do is you have to, if you're asking yourself, you know, the probability that both events happen, you take the probability of the first one happening and then the conditional probability of the second one. So you're assuming that the first one's going to happen, okay? This is ignore this. This is from the textbook, but we're going to look at some examples of these, okay? So let's look on the next page. So the question's asking just for number 1 and 2, is it independent or is it dependent? And that's it. That's all you have to do. So for number 1, you have 3 white golf balls, you have 2 yellow golf balls, and they're all in a bag. You randomly select one golf ball to hit now and another golf ball to place in your pocket. So it says, you don't have to use a sample space, but is it dependent or independent? If you take the white ball out first and then you take another white ball out. So think about that for a sec. Okay, so that's going to be dependent because once you've taken the first white ball out, there are fewer in there, right? So the second one is affected when you take the first one out, okay? So that's dependent, right? The second one says your friend writes a phone number down on a piece of paper, but the last 3 numbers get smudged after being in your pocket all day long. Yeah, remember writing down numbers on paper? You decide to randomly, you probably don't, you decide to randomly choose numbers for each of the 3 digits. Determine whether guessing the first digit correctly and the second digit correctly are independent events. Okay, so think about that for a sec. Okay, so those are going to be independent. When you guess the first one, it has nothing to do with guessing the second one, right? It's not like, I don't even know how that would be dependent. That's independent. Okay, so we're going to do some calculations now. So for number 3, it says you're trying to guess a 3-letter password that uses the letters A, E, I, O, U, and Y. Letters can be used more than once. Find the probability that you pick the correct password U. Okay, so it says that the letters can be used more than once, right? So that's actually really important. Because, for example, let's say I guess that the first letter is A, the second letter could also be A, right? So in that case, this is independent because my second guess is not dependent upon my first guess because it could technically be AAA or OOO or whatever. So this is independent probability. And then remember, independent probability, we're taking the probability of the first event, which would be choosing the first letter, and then we're multiplying it by the probability of the second event, which would be choosing the second letter correctly. And in this case, there's actually three things happening, right? So the first, second, third. So we're then going to multiply that by the probability of the third thing happening. Okay. So what is the probability that you guessed the first letter correctly? Well, probability is what you want over everything you can get. So what you want, there's only one correct choice for the first one, right? But how many choices did you have? You had 6, right? A, E, I, O, U, and Y, that's 6. Okay, so you have a 1 out of 6 chance of guessing the first letter correctly. Now the second letter basically resets, right? So again, you have a 1 out of 6 chance. All 6 letters are still there and still one letter is correct. And then the third one, same thing. 1 letter is correct and you still have 6 choices. So that's going to be your probability. It's 1/6 cubed basically, or 1/6 times 1/6 times 1/6, which gives us 1 over 216, which is basically, if you do that as a fraction and then turn it into a percent, if we just kind of round it at the 100th, it's going to be 0.46%. So if you were putting money on that, it's not a great idea, okay? You have a 0.46% chance of guessing all 3 correctly, which makes sense. I mean, your chances are not that high. There's 6 letters for each. All right. Okay, so we're now going to take a look at number 4. So number 4 says you're trying to guess a 3-letter password. So same story, right? A, E, I, O, U, Y, but it says letters cannot be used more than once. So that's important, right? Because that's saying that once you use a letter, that letter can't be used again. So that's dependent, because if I use E for the first one, I can't try E for the second one, right? So the second one depends on what you do for the first. So in this case, since it's dependent, we want to keep that in mind when we get here. Okay, so here's how we're going to do it. The first one is the same, right? So you have a 1 out of 6 chance of getting the first one right. But the second one, you still have a 1 on the top because the right answer, there's only one right answer. But how many letters are left to choose from once you've already chosen one from the first one? 5, right? So you've already chosen a letter for the first one. You only have 5 choices left. And then for the third one, there's still only one correct answer, but there's only 4 choices, okay? So that's what this is going to look like. You have a better... well, we'll see what happens actually, but you have fewer choices for the second and for the third because you can't use the same letters twice, okay? So when you multiply that out, that's going to be 1 over 120, okay? Which then if you turn that into a percent, right, so you divide it and then you move the decimal over twice, it's 0.83%. So you have a better chance because there's more restrictions, right? There's not so many choices. There's fewer choices because you're only allowed to use each letter once. Okay, so that's dependent. I know there was like the whole formula for dependent, you know, conditional and all that kind of stuff. It is conditional, but I think this is a really easy way to look at it, right? So there's 1 out of 6, right? For the first one, you've already chosen one, so there's only 5 left. Then you've chosen another one, so there's only 4 left. But there's still one correct choice each time. Okay, we're always multiplying in this case. All right, let's look at number 5. So 5 says the table shows the number of male and female college students who played collegiate basketball and collegiate soccer in the U.S. in a recent year. Find the probability that a randomly selected collegiate soccer player is female. Okay, so probability is everything you want over everything you can get. So let's start with what we want. We want a randomly selected collegiate soccer player who's female. So we want a female soccer player. So female soccer player is going to be right here, right? So that's 36,523. Now, it says that we're selecting it says find the probability that a randomly selected collegiate soccer player. Okay, so we're selecting out of all the soccer players. It doesn't say find the probability that a randomly selected college student, right? Or a randomly selected female. It says a randomly selected collegiate soccer player. So everything we can get would be here, right? This is how many people total that we are choosing from. We're not talking about the basketball people. We're not choosing from them. So we're choosing here. So you would add those together. When you do that, you get 73,763. Okay, and then you would use your calculator and you would go ahead, divide, move the decimal over 2 places, and that's going to give you 49.5%, so almost 50%. Which makes sense. Let's look back up here, right? The females are a little less than the males, just a little bit less, so it's a little less than half. All right, let's look at B. Find the probability that a randomly selected male student is a collegiate basketball player. Okay, so let's start with the top. We are looking for a male who is a basketball player. So that means here, right? So that's 31,863. And then we are selecting from male students. That's the whole group that we're pulling from the pool, right? So all the male students are going to be here. That was great. So you're going to go ahead and add those together. And when you do that, all right, so our bottom looks like this, so 69,103. And then when we go ahead and we divide that, and then turn it into a percent, that gives us about 46.1%. Okay, so you are now going to move on to the practice. So you'll notice that there's 4 on this page and then a couple on this page. So you're just going up to number 6. If you have any questions, please reach out. Let me know if I can help with anything, and I will talk to you guys soon.